So with inequality signs and we have a less than, we're going to have an and when you have the less than, and we're going to have or when we have a greater than sign. So if we look at this first problem, we have a less than. So we're going to create, because absolute values, two equations. So our first one is just x minus or less than 3. And the next one is switching the sign and changing the sign, because that's the rules of absolute values. Now we have our two inequalities that we can then graph. And so I'm going to graph the first one, 3. And the first one is an open sign, and it's going to go towards the left. And I'm going to erase this because I want to our second equation to be in blue. So our second equation in this case is the greater than -3. So now I go to my -3, open circle, and so remember the ands create an intersection, or they come together. The graphs come together. So there's the answer to letter A. So let's look at letter B. So we have an inequality, but it's a greater than. So we're going to have an or, so the graph should go out. So let's see how that works. Our first equation is what we see, great. And then our second equation is flipping the sign and changing it. So now if I graph the 5, it's an open circle and it goes away, which is exactly what the inequality shows. And then if I go to a -5 and open circle, and it also goes away, and that's what the or stands for. So when you have you have graphs coming together, or you have graphs going out, but you create your two equations from the absolute values. So let's look at our problems over here, same way. T less than, so this is going to be an and. So I got my t less than 6 and then I have my t greater than a -6. So I can then go on my graph and go to 6, open circle in this case, and I go left, and then I go to a -6, open circle, and I go right, and they intersect to each other. We have another greater than, so this is going to be an or, so t greater than 3 or, and then it's going to be t less than a -3. I can do my graph then. So I go at a 3, open circle, and go to the right. And I go to a -3, open circle, and go to the left, and my ors go outward. Okay, graphing multi-step doesn't change the process we've been doing. So I have a greater than, so this is going to be an or type of problem. But I'm going to create my two equations. My first one is what we see without the absolute value, 13. And then my second equation is going to be 6y minus 5. Nothing changes, but then I flip my sign and change the other side to its opposite sign. And now if I solve this equation, so if I add 5 to both sides, add 5, 6y greater than 18, divide by 6, y greater than 3. There's my first equation. Add 5, 6y is in the -8. And divide by 6, I'm going to get y less than -8, 6, or 4/3 negative. So now I can graph this. So I go to my 3, and it's a closed in circle this time because of the line underneath, and I go to the right, which makes sense. Then I do the left one, but -4/3 is somewhere between -1 and -2. So it's about right in here, but it's going left. So it doesn't matter that we get a fraction. What matters is that the inequality tells us which direction it goes. Because it's an or, they go away from each other. All right, let's look at our next inequality. This is a less than, so this is going to be an and. That means they should be coming together. So I got 5z plus 2 less than 17 minus 2. 5z is less than 15, so z is less than 3. There's my first. And I'll just do the second one here. 5z plus 2. I change the sign, and then solve. So 5z greater than equal to -19. So z is greater than -19 over 5. or 3 and 4/5, negative 3 and 4/5. So on my graph, let's graph the red one. I go to 3. It's a filled in circle, and I go to the left. If I go to a negative 3 and 4/5, it's between negative 3 and negative 4, and it's going to be a closed in circle, and it goes to the right. Our ands mean they intersect, and they do on this particular graph.